Good morning, everyone. Hope you guys are still pumped and full of coffee and energy. I will run this a little bit shorter, so maybe you'll get a bit of time back. So I've been in SEO since 2012. I am from Brazil, but I've been living in Ireland. I've been at Indeed for the last 3.5 years. And I'm speaking in a bunch of events. You may have seen my name out there, Brighton SEO, Croatia SEO Summit, and some other places. And let's go. About a year and a half ago, you guys probably saw this article from Mike King as well. And I remember very vividly trying to understand what the hell he was talking about, because it was a Saturday, and my daughter was taking that little afternoon nap. She was 2 at the point, and that's the moment that you're like, okay, let's have a little break now. Let's just do nothing and recover the energy. But my wife was working, and I thought, oh, I'm going to read this article. And I spent about 2 hours, all of her nap time, trying to understand what he was talking about here. And I had to read that a couple of times until I understood that something that I could do with this vector embeddings thing. And then I wrote my own article in my own words, trying to simplify what I understood from that Bible. And I wrote in a few places on my own blog. I wrote on Screaming Frog. I got quoted in a bunch of places by people that I really admire. So I kept exploring what else we could do with vector embeddings. And this is the dumbed version of this. I'm sure someone here has a better explanation of what this means and how to translate this. There are more technical people than me in this room today, so sorry if I'm butchering any phrasing here, but for me, vector embeddings are numerical representation of words, and they create a content corpus. And once you combine that with cosine similarity, you measure how close the corpus from different pages are from each other. So you're essentially trying to compare similarity between different pages. And we're going to go through 3 different tools today. You may do things without Screaming Frog. That's also very possible. But my step-by-step here is ChatGPT, Screaming Frog, and Google Colab, which is a easier version of Python. I'm sure Elias will talk more in his workshop tomorrow, but it's essentially Python on your browser. You don't have to install anything. A bunch of things already come in there. You just colab.google.com, and it's there ready for you to use. And it kind of breaks a lot of that barrier to install Python, which honestly, I failed many times before. And okay, I'm not going to talk to you through every single prompt that of the tools that I'm going to showcase today, but I just have one example, and it's honestly very simple. There's no layers of prompts and personas and different things into this. But this is what I asked ChatGPT. I'm asking for a Python code, but I specify that is from Google Colab, and I explain some of the things that I want, and all the information I get very specific about. I'm going to have this information in column A, I'm going to have this in column B, and a little description of what I want it to do. And I say I'm going to upload a CSV that has this information, and in return, I want another CSV that will give me the answer. So this facilitates some of the steps that sometimes the file is not downloaded, or it's saved somewhere that you can find. So little things like that. And we're going to build 5 different tools today. Some of them I tested and I use. Some of them are just ideas that you may grab it and take somewhere a little bit better, or make your own, angle out of it and make a proper use case for you. And there's a mix of all of them are using ChatGPT to write the code for you. Some will use Google Colab, or all will use Google Colab, and some will use Screaming Frog. So first, we're going to map related articles. So this is the use case that I had. I have this section on blog posts that you can add 3 links at the end of it. These are just related pages. And And indeed, the pages are, a very large number of pages, and essentially had thousands of articles that didn't have any matches there. They were just empty slots that we could add links to it, but we didn't do it because the volume was so big. We didn't have people to actually go and do all this work. And when they were doing, it's a very manual job. There are a lot of matches that would make sense to be there. And essentially, we built a way to do this automatically, or at least a draft that you can go and say, OK, does this link make sense to be here? And it's much easier just to sense check the information than just trying to come up with it yourself. If you have 30,000 pages and you're like, could be this article, could be this article. There are a lot of matches that would make sense. So using AI will take some of that boring work out of the way. And this is the CSV example that I upload. So you have the URL, and you have the list of embeddings. I got the embeddings through Screaming Frog, so the usual crawling with the ChatGPT API. But this is what I upload to my Google Colab. And this is how it looks like. I didn't write a single line of code. I just put the prompt, and then got the whole prompt, and I put on Google Colab, and I press run. The only thing it's going to ask me is the OpenAI API. But if there was a broken line here, if there was something out of place, I wouldn't actually know how to fix it. A few things when you start looking will say, the model you want to use, and like there are little configurations that you're like, oh, okay, if I can read English, I can guess what's happening here. So you don't really need to be a software developer, as we learned earlier today, and it was very eye-opening for me to look at Python from that angle. But that's it. So this is the outcome. I just made all the examples very short in the number of sheets, number of cells you see on the screen. But the lists are very big. So I'm doing this for 10,000 pages at once. And you can, just by looking at the URLs, you can see they are close enough, right? So I'm going to read this one. How to pace yourself at work. OK, how to organize your desk, how to plan your day, how to set priorities. They do make sense to be related articles to each other. So I think it's a good step to how you can do this. Then my second example is on CTA matching. And this is the case that I had. I actually used this, and it works pretty well. Again, massive number of articles. That a lot of them are about specific jobs or specific professions, but you don't always have a CTA that actually made sense. So when this was initially built, we had a team of engineers that would just say, well, let's just put a box with a CTA here. So you have part-time jobs, remote jobs, but nothing specific to that article. And I took the taxonomy that we have internally and used that as the reference for the CTAs. So now I have, if the article is about jobs that you can do remotely, or if there's something more specific, you have things like travel agent jobs or virtual assistant jobs. And all this mapping was done kind of automatically. So here again, I upload a list of URLs and a list of tags. These tags are all predefined. And exactly that same prompt. I'll give you the collab at the end of the presentation that you will just upload your CSV with all this information. It will do those things for you. And again, don't know how to write code. ChatGPT is doing it for me. I just upload a CSV, and I check if the results make sense. If they make sense to what I'm expecting, then I know I can do more of it, and I'm satisfied that I am achieving my goal. And here's an example of the outcome. I made a small version of this, and I made sure that there were not enough tags that would match exactly what the article was about, just to see what would show up for me. So I have a page about the barista CV, and the closest tag they had was barman. It's not really the same topic, so it's not really a good tag for me to put in there. but it gives me a sense that what is the score that the tool is giving me back, if it makes sense or not. So, just by looking at it, if the score is 0.40 or higher, it means that the tag does make sense. This might change in every case, and it might change if we have a bigger list and you start saying, some of these are not quite right. But it's much easier to start from here than just going through. I have 10,000 different job titles. Let's see which one is a list for a match for this one or that one. And in this specific case, the idea was to optimize for users. Can you believe that? So as people came through the page and they would see the CTA, we wanted to see, are they going to click on those and go and apply for a job? And these are the two groups. The dotted line is a control group, so those pages didn't have any change. And the full line, the black line, are the ones that actually had a change, that have the new tags. They all had the same level of clicks before, so the behavior was very similar in terms of what the users were doing. But you can see that, surprisingly, using the right CTA, it actually attracts more people to take an action on the page. Then we're going to go to Hreflang mapping. And yeah, over 50,000 pages in 20 countries. It's a very manual work to go through. Okay, let's see which one is the match for this one and that one. And it's just a very boring piece of work to do. And one more time, I use this Google Colab code using vector embeddings and cousin similarity to generate the drafts instead of doing this one by one. And one more time, this is my CSV. It has 3 columns, the locale, the URLs, and the embeddings. So here I got the embeddings from Screaming Frog. So there was the previous step, just go on Screaming Frog and say, get me all the embeddings for all of these pages. And then I just upload this on my Google Colab. And again, this is something, it works for my case. It makes sense, the results that I see it. I still need to go and compare. I'm going to get like a blind test, go to a website that I'm not involved with, see what they decide as good Hreflang matches, and I'm going to run the tool to see if it's doing, if it's finding something similar. It works in multiple languages. I just kept the English examples here, so it would be easier for people to take a look and validate, but I'm mixing here pages that are in French, in Spanish, in Portuguese, and the results in general are pretty good. Then let's go to a content gap analysis. I know a lot of SEO tools already do this, and we don't necessarily need a new one. But I wanted to compare the whole content of a page instead of looking at the keywords. So it's essentially almost like a page gap, if you will. And I wanted to match one specific brand versus their competitors to see which pages one have and the other one doesn't have. And I'm estimating the traffic that it's being lost there based on the whole page and not just the keywords. So I put here 2 of our favorite tools side by side as competitors. So I took SEMrush as the brand URL and Hrefs as the competitor, just to have a bit of fun. And so what we are seeing here is the pages that one have and the other one doesn't have, and using the competitor traffic as a proxy to say, if you create this page, this is the potential that you could have. Not perfect. Ranking, positioning rankings are affected by a multitude of other things, but I still think it's a good proxy to find gaps and opportunities. And you can actually get like a whole crawler running on Google Colab. So in this case, I didn't include Screaming Frog as part of the process. I just said, I'm going to give you a CSV with 2 companies, with 2 lists, compare column A to column, extract the embeddings from column A and column C, and use cousin similarity and tell me which ones where is the gap between one group and another group. It is a bit slow when you're doing this straight on Google Colab, and I can promise you that it's not factoring other things like it's looking at the header and the footer, like with Screaming Frog or other crawlers, you can select to remove this. In my case, I just crawl the pages. But I'm sure there are ways that you can do this. You don't necessarily need it because they're pretty much, pretty good tools that do this work for you. But I just wanted to see if it's possible to do this way. And again, the outcome was still good enough. This is just a sample of the pages. Don't quote me on this. Maybe those pages exist already on one website or another. But this was one example. So Hrefs has a page about Google search operators. And the closest one that we found on SEMrush, based on the list that I had, was on techniques to boost organic traffic. Not quite the same thing. So there is a gap. Yes, there's a gap between the content of these two pages, and that's the opportunity. So you can go and analyze and say, maybe I could have a page about this topic as well, if it's relevant for my company, my client, all of that. And this is my last example. It's still something I'm trying to figure things out, and some people will say this is just spam, and that's fine. I haven't really tested this, but I'm curious to see if there's something that we can learn from it. So my theory was, can I compare the content of the answer from the AI mode or AI overviews with the pages that I have on my website and see if they have any similarity? Because maybe you have that old classic case that Google is just showing long-form content pages for a query, but you have a client that says, I want my product page ranking here. Like, it's not going to happen. All the answers are reviews or listicles. Your commercial page will not show up here. So maybe this will be like a case like that. We expect the page to be in a place, but the content that we have is nowhere near what Google understands as the answer. So once again, this is my CSV. I have the URL, I have the page content, and here I just pasted the whole text. And I have the answer from AI overviews or AI mode, which I think at this time I used Profound to scrape all the text. You can also do manually, and I think all the other AI tracking tools will give you the text that is showing up on the AI answers as well. So it's just a spreadsheet. There's no other Screaming Frog. There are no actual extra steps in here. And here we go once again. I have my prompt or the AI mode answer, and I have I actually added a prompt in here as well, so I would have a reference to look at and not just here's a massive text to find out which one compares to what. And the best matching URL, in some cases, I don't actually have a page that matches too well, and in many other cases, it was not the page that I intended to put in that place. So that might explain why a certain page is ranking over another one. It might not. Tons of other factors in play. Content is not the only thing that defines ranking, but I thought it was a good step to poke around and see if there's something to discover from it. Yes, very important, because I got this question before. I'm just using the standard models that the tools are giving me. So for ChatGPT, I'm using text embeddings tree large, and for the AI mode, that was the last case that I show, I'm using the Gemini API, so the text embeddings 004. These are just the ones that they gave me straight away when I'm prompting, so there's no other extra steps that you're doing here to make sure these are used. This will show up for you anyway. And yes, my daughter makes to the stage to every presentation that I do, and this is her running around Dublin and making me very worried that she's going to fall in the river. But I have a couple of more use cases before we wrap it up. These are just with Screaming Frog. So you can see now, I think the latest version or maybe a few versions before, you can use vector embeddings and consistent similarity to find duplicate pages on your website and to find pages that are off topic as well. This is just done straight out of the bat with Screaming Frog. You don't need any extra tools, no Colab or ChatGPT for this. So they just do, you need the OpenAI API, but they do all of this in the software for you as well, and I think those are very handy use cases to have. And that's all I have for today. You can get all the Colab stuff on this link. I'm going to upload the slides as well, so you know you can follow one or another, and that's all there for you. Thank you for listening.
Thank you. Thanks a ton, Gus. That was awesome.